Okay, a short lesson on how to do 3D graphics. The idea starts with artists who were first learning how to do three-dimensional perspective drawing. And you can just picture an artist with a stalk here on the ground, and they know exactly where to put their eye, and they look through a window at an object. And let's just draw a little goblet out here. Now, when you look through the window, all of the light from here has to transmit through the window and enter the eye. And if we put little grid marks on the window, you can just picture a light ray from here traveling in every direction, but one of those light rays is going to have to come through here and then maybe come out right here and go into the guy's eye. Well, by looking at this grid, we can now tell exactly where this object in 3 dimensions would appear on a 2-dimensional screen. Well, that 2-dimensional screen is going to become the canvas. And imagine we put a canvas over here to paint on. And there's also a corresponding grid here. And whatever the coordinates are for that point that shows through, the artist would then go ahead and plot that here. I'm looking through the canvas. And maybe a point up here comes through and it comes out over here. And so that point would now get plotted up here. And after a little while, all of these points that the artist would see coming through the window will then be transcribed onto the canvas. Well, we need to do something like that with a computer. There'll be an object, and we're going to have to imagine that the light is going to pass through the computer screen. And of course, where those points appear on that screen will depend on how far back the object is. You just picture if this point was back here, it would be shifted a little higher on the window. And it would also depend on where our eye is. If our eye is closer or further away, that changes the perspective. So we need to develop a little bit of math for this. And the math is really not that hard. It's just simple proportional triangles. Okay, so let's set up a little coordinate system here. This is going to be the computer screen, and we're going to have an object out here. I'm only going to work with one point right now. And we have to define where that point is. I'm going to say that the point has a depth of z going away from the screen. Define this distance going this way as an x value. And then this distance going this way will be a y value. So the point has a coordinate of x, y, and z. Now I'm going to define a place for my eye. And that's going to be defined by z naught, x naught, and y naught. So I'll have an x naught, y naught, and a z naught. Now you have to imagine that there's going to be a ray of light that's going to come from this point behind the screen and then emerge from the screen and strike my eye. What we need to know is what will be this value. I'll call it xs for x on the screen and ys for y on the screen. So I need to take the 3-dimensional information and compress it to 2-dimensional information, and then that's what will get plotted on the computer screen. What we'll do is break it down into 2 parts. First, we're going to look at the picture just this way, and then we'll look at the picture from the top. So here's our side view, and what we need to do is try to figure out the height of this point going up this way. Way to do that, similar triangles. You can probably see it. We have a large triangle up here, and we have a smaller triangle right here. This distance, that side, will be y naught minus y, minus this height here. It would be over here. That height is going to be compared to this entire distance, which would be z naught plus z. So that triangle is similar to this triangle right here, where we'll take that height, which is going to be ys minus y, ys being from here to here, minus y over z. What do we have to solve for? We have to solve for ys. Well, that should do it. All we have to do is bring the z over and then add y. And here is the equation that takes the information in the z direction and in the y direction, takes into account where my eye is, and gives us the value to plot on the computer screen in the y direction. Now we have to do the same thing in the x direction. Now you have to imagine you're looking down from up above. And again, you're going to have a point over here. And now this distance from here to here is going to be still z. This is going to be your x value. And going this way, we're going to come out to here. That'll be my z naught. And I'm going to come up here. And that's going to be my x naught. And boy, does that diagram look a lot like the last one. How are you going to find out what the value of this is going to be xs from here to here? Again, we're going to do the similar triangle. Well, you can see that it's all the exact same geometry. Just change the letters. You're going to have x naught minus x over z naught plus z times z plus x equals xs. You don't need any of this anymore. And so here's your equation that compresses everything in the x direction to plot the distance on the screen in the x direction. And here is how we're going to plot the distance in the y. So what's that look like back in 3D? So here's what things look like in 3D. We have the computer screen. We have the point back here. We have my eye up here. And now you have to imagine that one of those light rays is going to strike my eye. It's going to have to come up through here. And right here is the point we want to plot on the computer screen. And this is going to be your xs coordinate and the ys coordinate. So take a look at the two formulas. You've got all the information on 3D here and ending up with just 2 dimensions. This sounds like a job for arrays. If you wanted to plot more than one point, you would probably have a whole slew of points collected in a 3-dimensional array, and then one for x, y, z, and then you could compress that to those 2 coordinates and plot that on the screen. Good luck. Quick basic.